Okay, we are live. Take it away, Rachel.
Hello, everyone. Welcome to the February edition of the Audio Programmer Meetup. This is a meetup we host on the second Tuesday of every month, where we discuss all topics related to audio programming. Thank you for joining us tonight. Firstly, I'd like to thank our sponsors. Our sponsors are Juice, Sonox, and Focusrite. Thank you very much for sponsoring the Audio Programmer Meetup. Tonight we have two wonderful guests for you. Those are Stefano D'Angelo and Gaurav Dayal. I'm going to pass over to Josh and he's going to tell you a little more about the guests we have today.
Yes, thank you very much, Rachel. And it's Rachel's first month actually hosting this. So thank you once again, Rachel, for joining for these meetups every month. And we do have some awesome guests with us. We have Stefano D'Angelo, who's tuning in from a mountain in southern Italy tonight. He is from Orastron. And we have Gaurav Dayal, who is the CEO of Beat Skills, and he's going to impart some wisdom upon us about how to start our own independent audio plugin company. We're always looking for people to submit talks for the Audio Programmer Meetup, and you don't necessarily need to be as experienced as the two people that are with us today. You could also be a university student presenting your first ideas on DSP or an interesting project that you're working on, and we would love to hear more about the things that you're working on. And rather than give you the link, I've just actually written it in the video description, so you can actually click in the video description and it'll be the first line there to submit a talk, and you just hit that, submit your proposal, and we would love to hear more about what you're working on and see if we can get you involved in one of these meetups. So we hope to hear from you. And with that, I will pass the mic back over to Rachel, and she will introduce our first speaker.
Thanks, Josh. So it's my great pleasure to welcome Stefano D'Angelo tonight. Stefano is a music DSP researcher and engineer specializing in virtual analog modeling. Stefano has been in the field about 10 years and is the engineer behind Arturia's virtual analog models of classic analog synthesizers, including Buchler's Music Easel and EMS Synthi. More recently, Stefano founded his own DSP consultancy called Orastron. Earlier this year, Orastron released a library of DSP modules in order to assist companies in developing custom audio DSP applications. So Stefano is going to show us an example of those modules in use and speak to us about the process of developing engines for audio hardware and software. Over to Stefano.
Thanks. So, yeah, thanks for the introduction. It was perfect. And let's jump right into the presentation. If I can manage, can you see it?
Yes, we can. And just to let people know, if you have any questions, please feel free to ask them in the chat. Just please precede them by the word question so I can see them very clearly. And we'd love to hear any questions, no matter how beginner or advanced you may be. Please ask away. Take it away, Stefano.
Okay, thanks. So I've been already introduced, and I just want to say that this talk is about developing engines for audio hardware and software, which is what I do daily, actually. So actually, this presentation will be split into parts, one of which is very boring, but necessary for the second part. The very boring part is about my history, and this will be preliminary to the technical part, which is maybe a little bit more into the things that are of interest for us, but we will talk about it later. So I'll try to be as how to say, unembarrassing to myself as possible, but let's go. So this is my story, let's say. I started taking a computer engineering degree from the Polytechnic of di Torino, which is in Turin, northern Italy, in 2010. In the same period, more or less, I was participating to some free and open source software projects, and that's something I'm not particularly proud of because of how those things turned out. But anyway, there was some audio stuff that was being done. Then from 2011 to 2014, I moved to Finland, to Helsinki, to get a doctoral degree in acoustic and signal processing under the supervision of Professor Vesa Välimäki, who is a huge name in music DSP. Then when I left, I went working at Arturia in Grenoble, France, and I've been the lead DSP engineer for 3 years there. Then I left because I'm a little bit of a mad person. I went back home to southern Italy, where things are much more difficult, and started freelancing. And I've been very successful with the freelancing stuff. So last year, I also started my own DSP firm, still here in Italy, in this small town in the south. I am the author of 12 international scientific papers, and I'm also officially recognized by Italian and French authorities as an expert in the field, also for research tax credit purposes in France. So if you have a French company, feel free to contact me. You'll have some tax credit. So let's start with Arturia, because I did my studies, and those were studies. You can find out stuff very easily if you're interested. I've been working, as I said, in Grenoble, France, which is a weird, yes, but also a very nice place. It's a very small town close to the Italian Alps, Italian-French Alps. I don't want to take ownership of the Alps in the name of my country, of course. And I've been working on some interesting projects like the Buchla Music Easel, which was mentioned before, and other things back then. Then I have to say that the people who were working there were exceptional in many ways. There were people who were capable of incredible things, especially in the hardware department, like the people who designed Polybrute now, but it was the Matrix Brute back then. It's unbelievable people. And the organization is very good as well. And indeed, now the company has grown much bigger than it was at the time. But as I said, I'm a little bit mad, and I wanted to be independent at all costs, mostly to do two things: to do more things that were related to the DSP work. So I wanted to do more different things, and some of them more in depth, at least more than it was possible back at the time. So as I said, I went back home and I started freelancing. This is the main square of my hometown now. It's 400 people village with 350 people older than 65 years old, probably. So it's a very small town. I'm doing virtual analog stuff as the things that I've done with Arturia, mostly classical synthesizers and guitar effects. I'm also doing some custom DSP algorithms from time to time. I've been doing some wavetable synthesis stuff, some dynamic processors, tuners, and other stuff. I'm back into academic research since I left. I've been doing some work on anti-aliasing methods, sound extrapolation, special math functions, and whatnot. And from time to time, I go consulting, teaching, do workshops, anything that's connected to the usual stuff. My current clients include Arturia, which everybody knows, I guess, Neural DSP, which is a company that's doing great stuff in guitar effects, both software and hardware. Dark Glass Electronics with the bass gear, both pedals and amplifiers. Elk, which is a Swedish startup that does some extremely low latency remote jamming stuff. And this activity actually allowed me to gain some insight on how projects are actually managed, how the specification process work, how the implementation of all the components actually is laid out, and then in general, how management of the projects is implemented usually. But this also meant having greater responsibilities because, of course, now I'm on my own. I need to respect all deadlines. Then there is the state, then there is the administration, taxes, and whatnot. So it's much more work than before. Then after 3 years of doing this, I realized that I was a victim of my own success in the sense that The activity was going really well, but I had too much work to be done. And the methods I've been using are really cutting edge on one hand, but on the other, because of being cutting edge, they have to be performed manually and are very error prone. And I had also the feeling of doing repetitive tasks, the same things over and over. So I had to find a solution, also because I have very little time to do other things that interest me, like going to the seaside or eating the food that is something extremely good around here. So my solution to this problem was actually to start this company that is called Orastron, and is still based in the same small town. So in order to solve the problem of having too much things to do and using manual methods, I started hiring people. Now we are 4, and it's people with heterogeneous skills, in the sense that I have a mathematician that works with me, and he's a pure mathematician. He does only mathematics. Then I have a computer scientist, which can do things that I'm not able to do anymore, probably. And then there is another person who helps me with the administration. Then I started doing some focused research investments on how to improve those methods and how to automatize them, and came to the conclusion that I needed to develop some internal tools, which actually we have now. Like we have tools for automatic analysis of circuits and stuff like that. And it's working, to be honest. Now we can develop things much more faster. I mean, much faster than before. Then for the repetitive tasks, as Raquel, is it Raquel or Rachel? Raquel, I guess. Sorry, I don't remember the names. As she said before, we've developed a small library at the moment, but it's growing very fast, of reusable DSP modules, and that's available for licensing, but we'll talk about it later. So let's get to the technical stuff. Now, I've followed some, I've watched some of the previous meetups, and I've noticed that people usually get their hands dirty with code very fast, which is not my approach. So I will rather concentrate on the mathematical and engineering part. If it's too complicated, I guess not, but if it's too complicated, don't get scared. It's not important that you get all the details. It's just to show the process of developing something, how the reasoning goes. So let's say that we want to make a volume control, which is the most basic thing I could come up with. What you want to implement is something that respects this formula, which means that your output signal will be your input signal scaled by some factor, and you control this factor. So if you go and code this, you'll get something like this. In essence, that is, you will have a process function which will create this output. It will be passed an input buffer, an output buffer, this value, and a number that says how many samples you have in each buffer. And essentially, you will just apply the formula in an iterative fashion on all of the input values. It seems very easy. It's not. This has 2 big issues. So the first issue is that you probably have, if you do it as we've done before, you will have not respected Fechner's law or Fechner's law. Again, I don't know how to pronounce names. I'm reading too much, speaking too little lately. So this is a law developed, let's say, found out by a psychologist, whose name was Fechner or Fechner, I don't know, which essentially says that in our case, the perception of loudness is logarithmic with the actual intensity of the physical stimulus, which I can suppose it means nothing to some people, but in practice, it means we need to work on the decibel scale and not on the absolute values for this kind of things like volume. The decibel scale is defined as with a power law such as that's shown on the right side of the line here. And we'll make an example to make it a little bit more clear, perhaps. We know from experiments that to get a signal to be twice as loud as before, we need to increase it by around 10 decibels, which means multiplying the signal by a factor of 3.16 more or less, which is the square root of 10 if you wonder, but yeah. by that factor. If you want this signal to be 4 times louder, you should not multiply it by 2 times 3.16, but rather by 10, which is the square of 3.16. That's what the thing means actually in practice. Another way to see the same thing is if you have a linearly varying intensity parameter, which is represented on this graph by the blue line, you will have a loudness, you will perceive loudness to change much more rapidly when the value of this parameter is low rather than when it's high. If you want instead to have the loudness changing in a consistent fashion perceptually, you should rather use a power law such as the blue line on the right side of on the graph on the right side here. So that's not enough still, because if you do that, if you apply a power law such as the one that we've been talking before, the first problem that you have is that a power law can never reach 0 because the argument should be minus infinity. And you don't have that on a parameter or a knob or something like that. Another thing that you might notice is that a power law can be converted to and from an exponential law. That's useful. But if you want to solve this problem in a, let's say, correct fashion or an approachable fashion, you can also notice that you can scale more or less an exponential to force minimum, maximum, and midpoint values. And that solves the problem here. And also, this law is more or less specified as potentiometer behavior, is specified and not respected in reality, but that's how things are specified usually. So I can understand if all of this looks like black magic, but we can translate it into code very easily. So the result is, now we want to use, rather than k, a function of k, and this function, if we want the midpoint to be 10%, you do all the calculations, you come up with this formula. So you just want to apply this formula. Here, the code shows how it can be applied. Essentially, you can calculate it outside of the audio loop. And that's what that corresponds to the numbers that you have above, just a little bit of calculation done beforehand. And then you apply this thing. This solves one of the two problems. There is another problem left. And the problem is the problem of zipper noise, which means that controls in audio systems are usually updated at a lower rate than audio itself. So you will have a stepping effect that will sound horrible to most people, at least, unless you want to do it on purpose, but that's usually not the case. So what you want to do is to smooth out this staircase kind of thing. And that can be done. If you can do that, actually you get the thing on the right, which, as you can see, changes a little bit more smoothly. And indeed, this is called smoothing. And the simplest way to do this smoothing thing is to use something called a one-pole filter, which is the simplest filter you can program in DSP. So instead of using a function as before, now we want to use another signal. So we are multiplying two signals. And this signal is defined in the case of the one-pole filter as a time recursive function, which means that the value of this signal will depend on the previous value of the same signal, and you will do a little bit of math just to have this thing implemented properly. You will have as input the function that we've seen before, so we can respect the chners law. And the value of these fixed coefficients that we have here, okay, I got a vocal message, whatever. The function that will, I mean, the constant that you have here can be computed in this way, which is one of the possible ways to do this. But I guess it's if you are into these things, it's the most correct for this kind of application, in my opinion. And it's a method called impulse invariant transfer or method or whatever, impulse invariance or something like that. You can find it on Wikipedia, by the way, so if you're interested. So let's put everything together. Now we will have, by the way, sorry, I forgot. This constant will depend on a couple of values. One is the sample rate, which is, well, the frequency at which the audio is updated, and that is known from the outside usually. and a value that you choose yourself, which I call tau here, and it's the time constant in some circuit. It's also called the time constant, and it basically determines how fast this filter will act, how much will it smooth. So we put everything together, and what we have here is the full code of the thing. We have, in this case, a global constant definition for the value tau, which in this case is 50 milliseconds, which means that to reach the final value, it will get from one step to another, it will take more or less 200 milliseconds, but I won't bore you with all these mathematical details, at least not more than I did already. Then you will probably have some functions to compute different things, like, for example, the sample rate is usually given very early when the plugin is instantiated or something like that, and it will not change. So probably you will have a function like this set sample rate here, in which you can calculate your coefficient. Then you will probably have a function to reset the state of the system. Essentially here you will set the initial value to the initial volume value to some value that you like. I set 0 because it's fun. And then your process function will just be more or less like before, except that here you will have this implementation of this one-pole filter. This line actually computes the filter with the formula that we've seen before. And at the end of the function, we will update the state. That's all. I hope that's clear, but if it's not, as said, it doesn't matter. It's just to show the reasoning behind all of this. So this can be still optimized. This is not final and so on, but at least you get a glimpse of how the things work and how many little problems you have to solve every time you implement anything in DSP. And that's a simple example. Now I want to scale you off a little bit more. And we will try to do the same thing, but without the code, because otherwise it would get too long, for a Sallen-Key low-pass filter. So a Sallen-Key low-pass filter is the simplest musical filter you can use in a synthesizer or an effect. And it's made of 5 electronic components. So now we start from a real circuit, well, kind of real circuit, because it's never this easy, actually, but anyway. So if you go to Wikipedia and search Sallen-Key low-pass filter, you will get these one fantastic equations. The first one is called a transfer function of the filter. That is a mathematical description of what this filter does in linear terms. And then you will have expressions for the cutoff frequency and the Q value, which is, well, Q is called also quality factor, and it's directly linked to the resonance. It's a measure of how much the filter is resonant. And as you can see, those things depend more or less on all of the component values that you have in the circuit. So if you're very lucky, you will know the values of these components. They will be given to you. That's not the case in most cases, I would say. So the first thing that you should do, even before starting DSP, in my opinion, is to try to understand how to set these values if you're not given them. So in regular circuits, you have that capacitors have fixed values, while resistors don't, which means you will only be free to set resistors depending on controls from the users and not capacitors. Then what you would probably think is that we need to simplify a little bit the formula we have before, and you can try by substituting some values, like expressing C1 in terms of C2, and expressing both resistance values in terms of a common resistance and some specific control values that I call V1 and V2 here. If you do that, those are the simplified formulas for the cutoff frequency and the quality factor. Of course, I don't know if you will find these formulas in textbooks or something like that. I hope so, but I had to compute them on my own for the presentation. So you don't have to be scared about these things if you want to really go hard into modeling circuits. Anyway, from this formula, formulas, you can also deduct what are the minimum theoretical and maximum theoretical cutoff frequency and quality factors. based on choosing the values of V1 and V2. And if you want to go completely insane, you can compute the values of V1 and V2 given cutoff frequency and quality factors of your choice. This is horrible, I know. Again, don't worry about the details here. What is interesting to notice, by the way, is that the cutoff frequency and the quality factor, that is the frequency and the resonance in this kind of circuit, cannot be independently set by changing only the value of one of the two resistors. So the things are coupled. And if you want to uncouple them, either you add more electronic components in the real circuit, or you have to control everything like digitally in one way or another. Of course, once you have full digital control, then you can also re-implement other, how to say, mappings for the parameters as you like, because you basically solved the parameter design problem. By the way, that was the first part. Then when you go to implementing these things, one of the issues that you have is that you have to approximate the derivatives that you have in the mathematical model of the circuit. And there are many possible choices. Here I show 3. Those are probably the most used ones. And these are not specific to DSP in any way. These are basically, they come from numerical integration, and they're common to a lot of mathematics, really, like numerical analysis and so on. And there are more, of course. And each of these formula will give you different results in terms of stability, accuracy, and time varying behavior of your DSP implementation of the, let's say, digital implementation of the analog filter. So essentially, in this case, we have for the first 3 that the backwards Euler gives better stability, but worse accuracy, and the thing goes to the other part of the spectrum when you go downwards in this slide. But still, I mean, you should probably know some things about the properties of these things before choosing one. And if it was not enough, you can also choose to have different realizations of the filter, that is, different implementation styles. Those 2 are the most common, and probably, well, I don't want to say the most useful, but the most common when it comes to implementing second-order digital filters, like the Sallen-Key filter we have just seen, but they can be also used for higher-order filters, as long as they are linear. The one on the left is called direct form 1. The one on the right is called transposed direct form 2. But there are more. There is some forms that are called lattice filters or normalized ladder filters that has nothing to do with, you know, commercial ladder filters. Then there is another one which is perhaps more useful in this case, which is called topology preserving transform, I guess, if I remember correctly. I don't use it, so I don't remember the name, to be honest. And there are others. And again, choosing one over the other gives you different properties in terms of stability, time varying behavior, and whatnot. So again, you should know what you're doing basically here. Then finally, if it's not enough, all of what we've seen until now, there is also nonlinear behavior. Now, this is also another complicated thing, perhaps even more complicated than the previous stuff. Essentially, in some circuits like this one, you will have 1 or 2 or 3 components that have nonlinear behavior, which makes things extremely complicated computation-wise, but also this means that probably we have distortion added to your circuit, which will mean, in general, more harmonics will probably cause some aliasing noise to be generated. And you have to take that into account as well. You can do that by oversampling or by other special techniques. At least the minimum is that you need to know that this can happen. As I said before, nonlinearity means that you cannot use linear methods that are the most investigated in mathematics as of today. So not being able to resort to these methods means that certain things become complicated to compute. That's how things are. So all of these apart, let's say that we want to make a simple model just for fun or not to feel too ashamed of ourselves. So one thing that we could do is choose some values for the components. I made this arbitrary choice here of choosing C2 to be 1 microfarad. That's one number. You could choose another number. And if you choose K and R to have these values, then you have that the theoretical minimum cutoff frequency you can get is 10 Hertz. The maximum Q factor you can have is 20. But then you could restrict in practice your range for both values. And actually you probably want to have the cutoff frequency mapped in a logarithmic fashion because it works like the volume. We have the same thing with frequencies in our ears. So if you use those magic values, let's say, the formula will be a little bit simpler and you can actually define a mapping from input parameters normalized between 0 and 1 and actual cutoff frequency and Q values. When it comes to discretization and realization, I would suggest to start by only implementing linear behavior. That's complicated enough. To use backwards Euler discretization to get maximum possible stability, because that's usually a big problem with digital filters. To use a realization that's a little bit more complex than the simplest ones, like the TPT realization or something based on state space, because those help with stability as well, and not to forget smoothing for parameters, of course. So let's set all of these aside. That's the hardcore part in DSP, but you don't necessarily have to do all of that to create a product. You can actually get something ready-made, whether from us or from anybody else. That's not the point. So actually, we have developed this library that I was talking about before, and we have implemented something very simple. Let's say it's very simple after you have implemented it, which is an autofilter. That is a filter that modulates its own cutoff frequency, which is structurally relatively simple in the sense that we use the input signal to actually we feed the filter that we use in this product with the input signal, but we also have a drive section just before it. And then we use the same signal to feed an envelope follower, which controls the cutoff of the filter. Then we also have a separated LFO, which controls, again, the cutoff of the filter. And then the output of the filter goes into a dry-wet mix before the output. That's it. This is more or less inspired by a few real products that exist. One is fantastic, thanks. One is actually the ladder module by Moog. Then there is a guitar pedal which is called Meatball by Lofton, which is a fantastic autofilter by itself, and also the Boss Auto pedal is a product of this kind. We have implemented this thing with our library, and it's actually usable directly in the browser. You don't need to install anything. We just have custom DSP code there running in the page, and it's compiled to WebAssembly. So we're not using any standard web audio stuff there. So I will show you the code of the process function for this little example. Essentially, we have this function takes an input buffer, an output buffer, a number of samples, as we've seen before. The first thing that we do here is to make a copy of the input signal. We've been extremely sloppy in doing it this way on the stack, but whatever, it was developed in very, very little time. Then we start with the LFO because it doesn't depend on anything. So essentially, we have a function that sets the frequency of the LFO, and this frequency is actually cubically mapped, which is a kind of exponential mapping as we've seen before, but not exactly. But yeah, essentially, LFO frequency is a parameter that is in 0, 1 range, and the frequency that we set for the LFO goes from 0.1 Hertz to 20 Hertz. So the next thing that we do is to set some output coefficients. Essentially, our LFO module allows you to mix different waveforms together. So we just set the mixing values for each of these waveforms. And we have different cases. The first case is the sinusoidal case. So essentially, we set the sinusoid output factor to 1 and all the others to 0. Then we have the triangular waveform. Then we have, what is it here? The rectangular, let's say the pulse, reverse so, etc. Then we set the pulse width, which affects only the rectangular and triangular waveforms. Then we have our process function for the LFO. Essentially here, all the code is contained inside this function and you don't need to go and code anything specific. In this case, I mean, in the case of this LFO module, we have many inputs and many outputs that are related to anti-aliasing, but we're not using them here, so it's all set to null. And then we take the last produced output sample as the actual LFO output. We could do it in a better way again, but we were doing everything in a hurry. Then here we use a one-pole filter to implement the envelope follower. Again, we have a threshold parameter on which we use a cubic mapping for its use to generate this the input for the envelope generator. And then we essentially do full wave rectification of the input, then we subtract the threshold and do half wave rectification. Essentially, this allows us to have an input that more or less resembles the loudness of, I mean, to have an input for the envelope generator that more or less is related to the loudness of the input. It's a small trick, but it works. And then we take, again, the output of the filter, the one-pole filter, as the output of the envelope generator. Then we have the drive section. Here we use a wave shaper class that has no special controls. So we need to do some gain staging before and after, and we also applied some smoothing. That's all about it. And then we finally have the filter section. So essentially we have two filters. One is a ladder filter and another is a wah filter. For the ladder filter, if it's been used the first time, we reset it, and then we set cutoff and resonant frequencies. Again, here the code is about mapping parameters and applying modulations. Then we have some gain staging, and we call the process function for the ladder filter. Instead, for the wah, well, instead it's similar. It's a similar thing for the wah. We set the wah position. Here we don't have a special control on the cutoff exactly, but rather on the wah the position of the wah pedal. Again, we apply modulations, we sum with the cutoff parameter, then if it's been executed the first time, we reset it and we process the signal. Finally, we have the smoothed dry wet mix. That's all. So, I don't know, maybe commenting all of this, it seems much, but essentially we could develop this thing in half an hour to an hour. I don't remember exactly. It was extremely fast. So, last two slides, I promise to not bore you too much. I just want to do a little bit of advertisement for the library that we're producing, just to tell you about the technical and the business aspects of it. So essentially, technically, we have developed something that we believe is very adaptable because it's developed in standard C. And we have also some optional C++ wrappers, but they are, as said, optional. We are not using the standard, not even the C standard library. There are no abstractions. We try to keep APIs as consistent as possible, but as said, without any common abstraction, there is even no notion of module inside the library. We do not use at the moment any CPU or platform specific code. If we will use it at some point, it will be optional as well. We've done some optimization, of course, on the code, and we give full source code access. We don't want to keep secrets with our clients. The thing is designed to be reusable in the sense that it's modular. There are many modules. Each is based on real world use cases. I mean, all of these came into existence because we didn't want to code anymore the same stuff over and over. The thing is very self-contained. The metaphor that we use is the usual patching metaphor that you can visually see, for example, in Pure Datamax and so on. The thing is easy to use, hopefully, easy to integrate in already existing projects or new projects, and documented. I mean, documented at this point, it's documented rather minimally, but we want also to produce some stuff that we publish on the website and perhaps videos, tutorials and whatnot. But I mean, we are only 4 people. It will take a little bit of time. The thing is robust, this I can guarantee, because each module is well defined. We've used scientific methodology from the start, so there is no trial and error going on. We know exactly what we want to achieve. Each module produces no side effects. So essentially nothing strange will happen outside of the module in any case. The thing is well tested and it's already used in production by our clients. So essentially there are musicians, and probably many of them who are already using this stuff without knowing. And I want to say that we are trying to make this thing a good complement to existing UI libraries and frameworks like Juice, which is a sponsor today, and we do not want to overlap functionality in any way. When it comes to business aspects, we are rather liberal, perhaps too much, with licensing, in the sense that we do not license the whole library at once, we just license single modules. We put no limits on the number of developers that can use it, or no limits on the number of products that can be developed using it. We offer an option for a time limit, in the sense that you can either take it with no time limit, or if you want to spend less, you can have this low-cost option with a 5 years time limit. And you'll get free bug fixes in any case. We guess that this is, we made it useful as much as possible for hardware application, mobile software application, like mobile apps, desktop applications like plugins and so on. And it also works on the web. We want to, we think this is a good option for independents, newcomer companies in this area, but also established companies as a mean to go faster, let's say, or to have newer and more reliable technology. There are many pros in our opinion. I won't go over them because you're bored and so am I. You can read them on the website. And finally, we also offer related custom services like ranging from just, let's say, education of some sort to the development of a full DSP engine. That's all. I hope you're still alive. This is our website. This is the email to contact us. We do not even have a newsletter at the moment. Everything is being rushed out as fast as possible, but we still live in Italy, so bureaucracy is trying to stop us in every possible way. That's all. Thanks.
That was awesome.
Thank
you. Brilliant.
Josh, you're muted.
Oh, wow. I was talking for about 10 seconds there and I was muted the whole time. Yes. So, yeah, a lot of people and a lot of activity in the chat with a couple questions. And Rachel, as a DSP person, if you have any questions, please feel free to interrupt me and fire away. So in the meantime, I have a couple questions. One question was that in the volume control, you talked about some other optimizations that you could make. And I was wondering if you could just talk a little bit about that. I was very curious to hear what that would look like. Okay, so on the top of my head, what I remember from the example, one thing that could be done is to reduce the update rate in smoothing. So essentially you don't need to actually smooth at every sample. You can get by smoothing, I don't know, each 4 samples, each 8 samples. Actually, this number should also depend on sample rate to do things properly. And that's one thing. The second thing is that you don't even need to use the
the standard library for computing the exponential, for example, because the standard math library that's used in programming language like C or C++ tends to prefer accuracy over performance, and in audio DSP, that's not our main concern, let's say. Those are the two things that come to mind. I don't know if there are others, actually.
Yeah. So a few people have commented on this already, and I wanted to get your thoughts. So there was a question just in terms of avoiding the standard library, and how much of an optimization do you feel that is? Do you feel that that's a significant optimization? Do you feel that it's kind of a 1% difference that will just give you a little bit more power? What are your thoughts on that?
It depends how much you use from it and what you use exactly, but I can say that savings can be enormous, especially if you do nonlinear stuff. Like, for example, if you use the standard library to compute a hyperbolic tangent, which is very common, the thing will probably implement some iterative method to get the correct result. And the iterative method will contain looping, branching, all sorts of stuff that's stall the pipeline of the CPU. So I don't want to get too much in detail here, but the thing is that it will be worse than you can realize if you just execute that part of code and test it. If you put it inside the project, it's worse than that usually. So you can really save a lot.
Wow. Okay. And Samex80 asked, in your volume control example, how do you determine the tau? Is that just an arbitrary number that you pick, or how is that actually determined?
The answer is yes, it's arbitrary in the sense that you can use any value technically, but in practice, what you want to do is to feed this control with a sinusoid, possibly around 1 kilohertz. The reason, I know that this is a little bit a pragmatic approach, but I know that the sinusoid is the waveform that is more suffering from zipper noise over volume. And I don't know exactly what is the theoretical reason behind this, but it's more or less known among people who do audio DSP.
Okay. Sounds good. Jacques Laplace asks, what is a good value in seconds to use for a sample buffer passed to these real-time filtering methods?
Sorry, I didn't quite get the question.
What would a good value in seconds be to use for a sample buffer? So how big should a sample buffer be to use for passing into these real-time filtering methods?
Okay, so the methods, as I've shown here, do not introduce any latency, if that's one of the concerns. Of course, that's not always the case. For example, if you have resampling oversampling, you will perhaps introduce some of these. It depends also on the techniques that you use. But anyway, there is a sort of golden rule for, at least for guitar effects. You don't want to get over, let's say, 10 milliseconds, possibly even lower than that. But those 10 milliseconds include the whole chain. So it's a round trip latency measure. So you want to take into account operating system, sound card, host application, whatever is in between. So I would say usually you want something that is in the range of 2 to 5 milliseconds maximum, and you compute that by dividing the number of samples by the sample rate.
Okay. Tugrul Akiz, and I'm sorry if I've mispronounced your name, asks, I've seen ladder filters used a lot in synths. Are there applications for biquads or Chebyshev or Butterworth type filters as well in the audio technology world? And I guess the answer to that would be yes, they're quite common actually, right?
Yeah, they certainly are, but it depends on the application. Like I wouldn't never use a Butterworth filter in a synthesizer. It makes no sense. You want something that's resonant, otherwise where is the fun?
Yes. And Giova asks, if you could suggest, if there was somebody that wanted to get into the same path that you're in, what would you suggest as a good starting point? Where would you begin your path?
Well, if you want to be crazy like I was at the beginning, I would suggest to get an engineering degree and possibly in electronics, telecommunications, or if you're less lucky like me, in computer engineering, and go on from there. If you don't want to do that, buy some good mathematics and especially signal processing books.
Mm-hmm. Great. Any other thoughts or questions, Rachel?
I think that last question's like sort of answered what I was going to go for, but I just saw a few people in the chat were maybe a bit taken aback by the maths and thinking, okay, like where can I find these kind of projects where I'm like a first kind of virtual analog modeling project to get into, where they can find somewhere to learn how to obtain the analog transfer function and then apply something like the bilinear transform and take that into the digital domain. I was wondering if you have any like specific recommendations for projects or resources that might be helpful.
So essentially, if you want to know how to derive a transfer function, again, I would suggest to buy a good analog electronic books. That's not DSP specific in any way. So analog designers use those things all the time. I don't know, on the internet you probably will find this information as well, perhaps even on Wikipedia or somewhere else. I don't know, because I did this stuff at university first, so I didn't search for myself. Then when it comes to the actual DSP part, there are some books or sources that I could recommend, of course. Even if I mean, as a beginner book, for example, I would suggest The Art of VA Design by Zavalishin, which is freely obtainable on the internet. That's a good book for starting out with these things. Once one gets a little bit more comfortable with this stuff, I would strongly suggest to avoid certain types of literature and go straight to publications from not the latest ones, because they are a bit more complicated, but scientific publications from early 2000s or something, especially from the DAFEX conference or ICASP. I mean, any conference that deals with this stuff.
Great.
Thank you.
Leo asks if you've ever used wave digital filters and your thoughts on them.
Yeah, that's an excellent question. I started with digital filters. Actually, I've published 2 or 3 papers on them. If you're curious, just go to my website or find me on Scholar, Google Scholar, or ResearchGate, I don't know. But yeah, I've used them extensively, even extended the theory a little bit. At the beginning, I thought that there were a solution to everything. Then I realized that was not the case. Let's put it like this. They are good for modularity, in the sense that you can build a circuit, and then if you change your mind at a certain point, you can change the topology very easily. The bad part of them is that their time varying behavior is horrible, and it's horrible because of how they're built. So if you want to actually have a product that needs fast modulations, don't use wave digital filters.
Okay, great. And we got another question from Tugrul, who asks, he or she or they comment, what is interesting to me is that there are serious efforts to emulate analog devices that are not well designed with some old approaches. And the question is the sound of old devices a habit, or was it really that good?
It depends on what you define, how you define good or bad. But to my ears, at least, some things sound really nice. That's all I can say. Other things, not that much. It's more a matter of fashion. And I mean, if you ask me personally, I'm a kind of guy who listens mostly to jazz, rock, and stuff like that. So I will tell you that clear amplifiers, I like them a lot. And maybe certain synthesizers I don't. But if you ask another person, they have completely different tastes. So it's up to you.
Yeah, maybe it's that our musical landscape has been so colored by these devices and that they just naturally sound pleasing to us now more than anything. Yeah.
Absolutely.
I wonder if it would have, I wonder what it would be like if it was the reverse, where we started out in this digital domain and then we went back to analog devices, if those would sound more pleasing to us, or if they would sound not very interesting.
I don't know, but I can tell you one thing. I was just playing before this little meetup with, Vice, the emulator of the C64, and I was listening to the actual sounds it produces, and it's remarkably close to the original thing. And I really like the noise of the Commodore 64, and I was using it when I was 3, 4, 5 years old. I guess that part of what we hear, if we like it or not, is related to our infancy, really. But you should ask a psychologist. I mean, that's certainly my experience. So perhaps if we were grown with digital technology, we wouldn't like analog one, possibly. I mean, it's very likely, maybe.
Yeah. Yeah, it's the question. Sometimes I think that like when it comes to a band playing together, it's the humanization of when you hear the Beatles, for example, and things going a little bit faster or slower. And it's, in my opinion, sometimes it's the imperfections that really that give it that sound that's so pleasing to our ears. And that when things are too regimented, that, I think as a music producer myself, that, we can hear the result when things are too regimented, when the hi-hats have no difference in velocity. Everything just comes out very mechanical and not very pleasing at all. So sometimes it feels that even though we're in the digital domain, that we're still trying to create the humanization by taking drums and maybe moving them off a little bit. And I find that very interesting, actually, that we actually put the effort into creating that thing that we sought to eliminate at one point in time, the imperfections.
Yeah, to add to that, Josh, I mean, I'm sorry I'm interrupting, but the proof is in the pudding. If you go to Reverb and you see the prices on old gear, even from simple digital machines like the SP1200, and so you'll see it's like they've started reissuing that with the original circuit. I mean, if one would logically think, what's the point to doing that? I mean, when you have such more refined circuits and perfected timings, it's all about, I think, two things probably. The simplicity of certain things also is very appealing. What is instant? Because the color is already done. Same with film. Like, why does Quentin Tarantino still prefer to shoot on film? What you just said, the imperfections, the impurity, there's the kind of certain color which we took for granted. And when digital came about, that we were stripped off that. Right? So suddenly everything's naked, and it's like right there. And like you say, psychologically, as Stefano was saying, psychologists might be able to tell why human beings, like certain kind of stuff. Like he's saying, there's a noise in the Commodore 64. Commodore 64, again, being a completely digital device, but all the aliasing and the noise and the A to D converters and the signal to noise ratio was not perfect. The converters were not designed to be perfect, but that noise factor or whatever just comes to that. Even your own point of hip hop, like for example, there's people place space between the transients, like they will actually add a silence before that. So when you play the drums, how that imperfect sampling is what creates back that groove as to or I mean, me being such an analog person, I was dying to comment on that, so sorry to interrupt, but I think it has its value. It's people are buying that stuff.
Yeah, I think those are very valid points. Absolutely. It's so interesting. You could take it even further and say, well, why do we have a different type of connection? For instance, when we're meeting in person versus meeting on Zoom. It feels almost like that can be applied.
Missing. Yeah.
Yeah, it's like that can be applied in a way to how we perceive sound as well. Why we find certain sounds to be very pleasing and resonating with us, and others to be
hey,
not so much.
Lo-fi is a whole genre now. Tell me about it. I'm making products. It's all, in demand genres. Like I was doing this, 4, 5 years ago, 6 years ago, adding this, and I was so badly battered sometimes. Who needs a product like this? Why are you adding? And I'm like, yeah, wait, give it 4, 5 years, and boom,
Yeah.
people realize that it's a style now. It's stylistic.
We have 2 more questions and then we'll wrap up. One question from Giova asking if you're a musician. Do you produce? Do you play yourself?
Let's say no. It's the short answer.
No. Interesting.
I was playing bass until I was 20, let's say. Then less and less. I got to the point where I take my bass in my hands like once every month or something like that. So no, unluckily.
Okay, great. And Michael Kaufman asks, do you have any guidance in terms of when to avoid the standard library or anything like that? Or would you take an all or none type of approach?
I try to avoid this as much as possible, to be honest.
Yeah.
I know that there are some cases in which it's not that much of a problem, like certain mathematical functions are implemented directly by the CPU. That happens, but you need to be sure about which CPU your code runs on. So if you can avoid it, it's better, in my opinion. And
a person in the chat, Martin, mentioned this earlier, and I'll mention as well. There's actually a pretty good game audio talk about this. I don't remember where it's at, but it's actually a game audio talk where they discuss avoiding the standard library. I think it was from one of the game audio conferences, but they discussed that and their reasonings for that and the various optimizations that they've made. So I'll try to find it and put it in the link in the description afterwards or something. But pretty interesting talk. I thought, wow, that's pretty deep.
Good. It means I'm not crazy.
Yeah, no. It's actually it's actually a pretty common practice within game audio when companies like Electronic Arts have their own version of the standard library, and I know music tech companies that do as well, where they have their own implementations of standard library functions. So, great, Stefano, thank you so much for that information. I know people found it really insightful, and I know that it's been a lot of fun and really educational for me as well.
Thank you for having me.
Yeah, awesome. Cool. So yes, I think we could move on to our second talk now. And Gaurav has previewed things to come, and I'll go ahead and just jump straight into it. Gaurav and I have actually been friends for a couple of years now since I've been in the industry. I've only been in the industry a couple of years when I think about it, but Gaurav has been. We've worked together a couple of times, and I'm really happy to have him here. He's the CEO of Beat Skills, another company called Tone Empire, and a few others that you may have seen in your travels if you're into buying plugins. And he's been nice enough to share with us a little bit about his journey, lessons learned, things like that, and that, there are many people that I know that are probably in this chat that are thinking about becoming independent audio developers, becoming contractors, starting their own plugin company. And Gaurav will have a lot of insights on things to do, things not to do, things to be aware of, and so on. Welcome, Gaurav. Thanks for joining us.
Thanks, Josh. I'll continue in the style of Stefano's self-deprecating humor. Stefano being very brilliant. I don't know how many people would be, this is the boring part of the chat, which is running a company. Developers hate that, all of the other stuff you have to deal with. And as we were mentioning before, you have to get a team to manage the logistics. So we're also like not a very large company. We're a medium, small size company. And we're also like about 7 to 8 people who are there. But primarily it's the same way. It's like divided into certain tasks. I think the biggest challenge that I think people who are aspiring to be developers, I think that'll be a question probably, is like, it's not as one part is hard enough, as you've seen with Stefano's presentation, is to make a really nice product, to make a functioning system. The other thing, and this is just the DSP part, then comes, the compatibility, where the sponsors, Juice come into play, and Juice makes it, much easier for us to actually create in one system and then have that deploy over, multiple types of DAWs and, even operating systems and machines and all of that. So that definitely is like a boon. It's an awesome tool. So it takes a lot of years to, even with all this technology and tools, to really understand what are the common problems you face in certain digital workstations. Because when you really take a product to market, you're going to face a lot of trouble. You're going to really face customers with different configurations, with different machines, with systems permissions which are not working. And then it's not a guarantee that your product, even with all the work that you've done, lands there and works. So customer support becomes, in that space, I think, the primary thing to focus on. I think when we learned, our company is about 5-6 years old now. So in our second year, we upped our game and started to focus a lot on customer support, because people need to build a trust with you. They need to know that in case it doesn't work, you're there to help them, and then the common problems, the answers to things, and that makes them very happy. And sometimes we just have to give refunds, because sometimes it just won't work, even if you catch their computer and you're remote controlling it, and there's some funny stuff going on which you can't predict. But most of the time, of course, with Juice and all of that, it should work. Now, obviously the DSP, what you're trying to achieve, why do you really make a plugin, becomes also one part, which is the non-scientific portion of things. I think because I come from a music background, I've had a 20-year career, I still, like I said, I'm actually a musician. So I come from that spot. I have a background of computer engineering, but it just stayed at that. It's not obviously as advanced as Stefano has gone, the whole route, and that's why he's so brilliant as he is. I come from that basic understanding of computer science and programming, and then of course music. So whatever we've been developing is, Josh, primarily coming from our own needs and our own feeling of what we think could be a very useful product, something that we think we can develop, which is very exciting to us primarily in the whole process, and bring it to the world. Our particular approach, and I'm not saying this is not all companies, but our approach is more stylistic, or it's more about maybe not reinventing or actually just inventing something completely new, but taking from what like filters, you've heard, sounds that you're familiar with, but maybe combining them in a process which has never been done before, or is uniquely very interesting together. For example, like using two technologies in our Tone Empire line. We're using convolution and we're using circuit modeling together. Because to my ears, like I feel like, for example, that convolution and dynamic convolution can actually capture nuances of gear, because it's literally like making a sample library. And, but again, it has its limitations, and combining that real imprint of the real hardware that you sample with the, diversity, the variation you can build with equations, which is just like, you can go in between, you can do this and actually model behavior. So when you do both of them, that's like a unique thing to us. I think that's our approach for some of the plugins at Tone Empire, and favorably so in our in our line of products, because people respond that say, hey, this actually, I can hear the those certain things as compared to just a mathematical model, because there are certain things you miss. Certainly, I'm sure Stefano will be able to. That's what he does. Models all those. The small things like you were talking about, the noise, the conversion, the aliasing. Now coming to aliasing, like we have a bit crusher plugin, which has got also convolution on top of it. So it samples the A to D converters like Samplex, that product. It captures the A to D, D to A converters. It also does the bit crushing with that kind of thing. So it combines two technologies where people also get like the filters and the stereo width of the sampler, not just, dividing the sample. And in this case, aliasing is a good thing. People are buying those SP1200s for like $8,000 for, pitching down the sound for the aliasing. So, you have these purists versus the, the old school guys. So it's catering to, two fields of thought or two schools of thought, like trying to make a very lovely compressor. The expectation is that, hey, at oversampling should be provided. So, there's least amount of aliasing. And then you have these colored products where there's like, hey, why don't we have a knob for noise? It would be great if you just have like a continuous noise sample or a noise generator, which adds that, that kind of vibe. So putting a product together then becomes more than just, a technological advancement or something. It becomes also about UI, like we've been appreciated or like for our UIs a lot. People say that, hey, you know what? It's so simple, it's so immediate, and it looks good. So does that really play a role? Because many people worry or have that, hey, why couldn't I just have a simple interface? And yeah, I mean, it works in many cases. Like some companies, they just have a flat, simple interface and it's functional. It's got so many functions. There's not really any scope for design. But being a creative person, I think it's a very important aspect. What do you do when you look at a plugin before you even hear it? You see it, you see a small thumbnail of it at a store. So why are people going to pick, your plugin over somebody else? It becomes a very, very essential factor. If it just looks like a gray box with some knobs, even before they can, put a judgment, it might be the most fabulous thing. It might be the most best sounding thing that you were probably looking for. But thumbnail, small thinking about that is not appealing or is not popping out of that store. It's not going to, it's just going to pass by. And you see something which is popping out, immediately you see some, controls which are appealing or large or simple. It, to a certain customer base, it does appeal. Not to everyone, maybe, but to a certain customer base. Then I think the longer journey, Josh, becomes about your audience, just like an artist. So then it's not really about feeding the market sometimes as to, oh, well, let me top that plugin or, let me create this that has never been done before. It becomes, you start knowing your audience. Your audience speaks to you. You will get tickets, you will get responses, you will get social media interaction. Social media interaction is something that, you just can't overlook. It is such an essential part of the audience of people really telling you. Some of it can be really funny, or it can be really, hitting you for no reason. And some of it can be really great criticism or really things, you can think it all, but sometimes a customer, even somebody, a newcomer might be able to tell you, hey, I wish it, there was a knob for this, or I wish you reduced the number of controls. And you think, and you're like, this is coming from another point of view. And it actually makes sense. It's so why not give the customer in the next update something that they were asking for, some very valid point. So if one is able to do that and not close oneself to just okay, I thought of this and I think I'm really superb, and and I do think they know more than me. It's like, if you have to give that up, you have to really be like, okay, I might be the most technologically advanced person and I might know this and that, but the smallest like user could tell you a small thing about it, about your product, which be like, wow, that's going to sell a lot more because it makes the job or the excitement or the usability more interesting or easier or whatever. So I think that customer base you build and what they say becomes something you should not ignore, because I think that's a pitfall. The first year you get really offended, but the first year you'll be a developer like, hey, I put all this effort and this guy's pointing out that zipper noise on the volume control. But you see, that's experience, right? You understand that, Juice has a function for that. It's called the gain with ramp option. I don't know if it's implemented the same way as Stefano saying. Stefano's method obviously is more complicated, might be even way more pleasing to the ear and more natural, like literally like a potentiometer than that thing. But all those things all those little things, they matter, because by the end, if they're using a tool day in out and they get really used to a tool, there has to be something, you got to learn what was special about that tool. And it's not always just the sound or the, the functionality. It's a lot to be like a connection. Like if I'm sitting here with a red Juno, I make a connection with this synth. I see it's got just one oscillator. It's just a single oscillator. So why are Junos selling like hotcakes, like a single oscillator synth? It's not even, it's so dependent on its chorus. You switch off the chorus, it's gone. But people just, just buy this like hotcakes, their emulations. So it's about a lot more things, than just sometimes the technology.
Yeah, you bring up a great point, which is that it is a lot of things. And so some people may be thinking, so where do I start? So I'm a beginning audio developer. I want to make my own plugin company. Sometimes people come into our Discord and they ask, what should I make? Where should I start? What advice would you give to them?
Yeah, I would say start with something that would be useful to you personally first. I mean, if you are a musician or you come from a background, even if you're an engineer, it could be something very simple like a filter. Okay, but you could add something to it which is very unique in its space, and if you have a reason to sell it to someone, like if you're selling it now, you're going outside your house, you're going, to an audience who already has so many options and so many stuff they already own. So the reason of, putting that out has to be strong, even though it's simple. Never be deterred by the fact that, oh, this has been done before, or, oh, my plugin Slamdog has been copied like a gazillion times. People have said the same thing. Like I feel because I was the first one who did that, I was scoffed at because they were like, oh, how can this be a bus mixing plugin with just 3 knobs? So from personal experience, I can tell you that it was the advertising or the reasoning or stuff behind it of being the most simple plugin on the market, but nobody combined something in that way, which gave you a mix bus compressor, just a low end knob, a high end knob, and a stereo expander. That's it, simple. So if you're reasoning the way I put it out there, I think the reasoning appealed to EDM producers. It appealed to a certain audience who was like, hey, I don't want to go through a 60 band EQ. Okay, I want to make a beat and I want to have 2 controls to fatten it up and thicken it up, or I need a filter which could just clean up this stuff, and it's appealing enough, or it's just got the right bandwidth or the right, like you say, mapping in a way between the frequencies. Just could be a simple thing like mapping. They just might not like the filters and some other plugin because it has the entire range and it's not fitting out well. So just that mapping that you went for was so easy that every time they turned that filter, they got to that point A to point B immediately. And that's it. Like you didn't reinvent the wheel, but you gave people a very strong reason, which you showed them why it's a great product for them to buy. So I think it comes from your own, need and story. Like, what's the story? So I think that's a key point. Yeah.
You bring up a great point, and I think that one thing that I think about a lot is about going against the grain of the trend, which sounds like something that is what you've done. If you look to the early 2000s, a lot of the tools and a lot of the plugins that were being created were kind of all-purpose plugins, plugins and synthesizers that tried to do a lot in one plugin. And now recently, it feels as though this has gone the other way, which is where you have a plugin such as Arcade, which has a very distinct identity. It's an identity that's not for everybody, but it's for a certain type of producer that wants to create a certain type of workflow. And
right.
You've done that with Beat Skills as well. So for people who may not be familiar with that brand, can you talk a little bit just about how you've found that identity for your brand?
Oh, thank you for that question. It's a lovely question, something I'd love to answer. So me being like a 80s kid, growing up in that time, I was exposed to all this pop music because synthesizers were new and drum machines and these things were new. So although I didn't have access to those things, but I grew up on that music and it stays with you. You know, as a child, what you listen to stays with you. So BeatSkills is a brand which is basically going to stick with everything, you know, kind of 70s, 80s, little bit of the 90s, you know, that's it. Like we don't go beyond that. It's not a crazy. So we're able to cater to that genre, you know, so like we're making old school samplers, we're making synthesizers, we're making, we already have very successful drum machines like synthwave drums and all, which are pretty much like on Plugin Boutique, the top seller. We've been told that in the synthwave genre, we have the top selling products, period. So that kind of proves the point that if you stick with one spot, which is what BeatSkills is about, and gets everyone who's in that genre to be interested in the products that you make, it kind of works out. So even us being limited, like purposely being in that space that, hey, we only make old school hip hop or synthwave or retro or, you know, keyboards and things like that. It's a kind of flavor. It gives you an identity. It immediately gives you that, oh, they're not making the next, you know, sound design, swish plugin, whatever. Great, good for people who do. But that following that is that cult following of sorts, that, man, the sounds we need, these guys have it. The controls we need, these guys have it. So I think that is kind of a brand identity thing. Like you said, with output, they have a certain workflow. We have a certain workflow. Our motto is less controls, more sound, or more variation, more colors. But the motto is it's not going to be a 13-page synth. We're never going to do that. The maximum we've done is a new release called Techno Keys, which is a 4-page synth with lots of things. But the reason we have these pages is like the first page is only minimal controls. It's like when you hit it, you can immediately start playing sounds. And with a few tweaks, you can really change sounds. If you want to go deeper, okay, go to page 2. If you want to go even deeper, you go to page 3 and page 4. But like I said, the concept is always less controls, the vintage way of working, fast and quick, immediate results. If I may sum it. So that's something we stick with at BeatSkills.
Yeah, that's really awesome. There are a couple questions. One question is from Jacques, who asks, do you have any advice on how to get customers? Do you advertise on Facebook? Are there any other better channels? How do you connect? When you were just starting and you first had this vision, how did you first connect with a customer?
Yeah, well, just do the basic routes of the free stuff first, which is go to forums like, you know, KVR. There's Bedroom Producers blog. There's a lot of places where you know, you can get news out for free. You don't really have to pay anybody, and that's the first step, because they'll just publish a news for free. So if you have something which is interesting, it's being exposed to a lot of customers, because this is at point where you don't have an email list. This is at a point where you're starting from zero. So that's the first thing. Because even for Facebook, you see, to use Facebook advertising effectively, you need to have some audience, because then Facebook can multiply that audience. They have tools like find similar customers, or, you know, find, you know, similar kind of people. Although you can tag and ride on other, names that you think your product is similar to. Say your product is similar to Arturia, for example. So, you know, you can use some keywords which are similar or familiar, that your ad can, you know, reach that kind of people. But I think Facebook is most effective, in my opinion, now, once you have a certain bit of an audience. Then you can use the real deep tools in that to, you know, to expand and go forth. Instagram is a great place if you're starting with nothing, because the more you demonstrate your product with the right tags, with a video, and it doesn't have to be fancy. It doesn't have to be with an expensive camera. You don't have to do all that kind of polished marketing. I think that even with all the polished marketing we sometimes do, the traction we get from Instagram still is very important. It's a very identity oriented place. So like I make a lot of videos with my synths and the plugins I use, and that really gets us so much engagement, like right there, that I think that becomes a great tool, and it's a free tool. Again, it's just free, you know. So probably start from there, and maybe go to YouTubers, you know, try to approach some of them like Josh, and, you know, see if you're developing something. He like he opens that fact that if you're developing something, call him, like, you know, they might feature you if you got something, you know, good going. So that's again a great way to put forth some advertising. Go to YouTubers who you think might be interested in your product, So yeah, I mean, that's the way, that's how you start, you build. Make a free product if you can initially to get a mailing list, you know.
I have a question that leads on kind of from that one, if that's okay. So you mentioned the importance of, listening to your customers' feedback and acting upon it.
Right.
I just want to ask about your process of gathering customer feedback in the development and release process, like whether you've got some user surveys with incentives that you send out, or beta testing, or whether you find that you can get enough information from like support, inquiries, and Facebook and Instagram feedback. Like, what's your kind of suggestion for the best way of gaining customer insight?
Yeah, it's a very tricky thing, but it's a great question actually. I think the initial thing, when you start out, it's like nobody cares, right? Because you don't have a product yet. So when you do start out, probably the best thing is, some people might not agree with me, but is to show the stages of the product you're making already on Instagram or YouTube videos, that, hey, you know what, I'm developing this thing, and over a period of 6 months or whatever, you've got like 10 videos out of 20 that I reached here. You will find that people will, who are interested will start engaging. Hey, what if it had this thing? And what if it had that? And that, I think, is a great way. Same with Facebook or whatever. So if you show the process, I mean, the whole thing is that if you show the process of what's going on, like some people might become very protective about their product and be like, hey, I don't want to show anybody could copy me and, do this. So it really depends on the attitude of the developer. Like a person like me, I'm totally free. I'm not doing anything that's not been done before. Let's face it. My strengths are really, my ideology. My strengths are my sounds. The strength is using what's around and making combinations. So if I go with that notion that, I'm developing something secretly, I'm not doing that. So for me, I'm free of that burden. So
Right.
with the case of Samplex, which is one of our popular products, the version 1, I did the whole thing for 1 year on internet. So by the time it came out, not only did it have certain things that people wanted very strongly, repeatedly, but it had automatically created a wanting and a longing and a buzz. So all I was getting was emails of, when is this coming out? I need this tomorrow. So compared to a blind product launch or a secretive product launch, I've realized that sometimes, this whole build-up of the process of revealing and talking and interacting gets your word out there, and gets you the information, like you said, you need.
Yeah, sounds like it's a good idea to build up that traction and excitement about the product. It's really good advice. Thank you.
Correct. But beta testing is also a great system, like you proposed. I think that's a good thing. Give out some, time licensed copies.
I was just wondering, like, I think people have said in the past when they've sent out kind of anonymous surveys, they've got more honest feedback than what people might give on like a social media platform. But from the range of what people have said to you on social media you described, it sounds like you have got some quite honest feedback.
They will tear you apart. Are you kidding? You don't need to, they will tear you apart. You'll get that feedback. Today people are not as shy as probably they were. But you never know, I mean, maybe the survey method is also probably very valid in its own space.
Yeah, you say a great thing, which is that sometimes you just got to try it, right? There are a lot of people who talk about trying to get it right on the first time and trying to just perfect the process, but sometimes the process needs iteration in order to perfect itself. Even with large companies, they have roadmaps. Like these things don't just instantaneously appear in their final form, right? These are companies that have a story that they need to tell, and it takes time to develop those relationships, and it takes time to tell those stories and make the connection. And you're bringing up a great point in that being able to tell your story is quite important. If you just approach somebody with a product, they don't know you and you don't know them, you have no connection in order to be able to get them to purchase. Sometimes you have to develop that relationship before you can ask them to buy in. Sometimes it's about giving before
taking. Yeah. And also,
before
see, you have to consider the fact that, you're in a very competitive market today. You have to really, digest the fact that even when I started out, it was competitive enough, but now it's even more competitive. So your reason, for sticking around a long time, I would emphasize that. Don't do it for a one-off thing and expect that if it doesn't work out, you really have to love wanting to make a product, that, hey, I want to make this anyway, whether this fails or it succeeds. Had I known the path that I would have to go through to get here and, seen all the failures and the pitfalls, I probably would have never done it. I would like, who's going to deal with all that kind of, customer support and like all this backlash you get and blah, blah, blah. So it really truly has to come from, the interest and the love of wanting to do, many things and hoping that some of it passes through. It's just the same 80-20 principle. You throw a lot of stuff on the wall, something will stick, but it will take a lot of stuff. Every product you're going to make is not going to succeed to that level. But there is one very beautiful thing in this particular software company running line of things, which is not there actually in the music business. This is the only kind of branch of music business which will give you this boon if you choose to be a developer and stick around. Is that, honestly, I don't have a single failure product. When I say this, what do I mean? That I don't have a single failure product. It means that even products which didn't pick up, say, in the first year of release, sometimes caught on the second, some on the third. So their shelf life is tremendous. It's like almost like old music was, you can still hear it. So it has this tremendous shelf life that if you've not reached your customer today, don't be in despair. The second product or the third product might bring you on the map, and then your followers will go and rediscover what's behind. It's like almost like I discovered Stevie Wonder in 1984 and 85, and then I'm like, I want to hear every record Stevie Wonder has made. Then I go back and I hear, what a great songwriter he is and his stuff from the 70s. And so, it's just like that. It's like discovering an artist. It's the same with this, except like I said, music won't sell like once it's been done and it's on the charts. But the products, the one ray of hope is that if you want to be a developer and if you can stick it around long enough, you might actually make it in a way where none of the things you made eventually were a failure. It'll catch up, So
absolutely.
Yeah.
We have a couple comments and questions from our audience. Paul Davis says, 10 years ago, I heard someone predict that the future consisted of devices with just two buttons, either one meaning that was worse and the other meaning that was better. And we seem to be getting closer and closer to that time. And Leo asks a similar question about this and asks if you see this many controls versus few controls different in different markets. So do you find that people maybe in Asian countries or in certain regions are gravitating towards liking a certain workflow over others? Have you seen anything like that?
I'll answer this part first. So it's not regional. It's actually a very discrete distinction. It's like musicians versus engineers. So people who are music people first, like play instruments, but are trying to also wear the hat of an engineer and wear the hat of a producer, will always gravitate towards less controls because their focus is not really trying to get into that 60th band EQ. They want to get done with it, and their purpose is that I wanted to sound great. So for them, the tools which get them there quicker in the engineering part or the creation part is more appealing to them. So those type of people will always appeal, go for that. The engineer people who are like more into like, I want to make this sound as good as possible over 5 days. I've been given music, but I want to tweak every aspect of its width and its saturation and this band and all that. They obviously like will gravitate towards as much control as they can get. But then again, there is a mix because nobody's absolutely only a musician and nobody's absolutely an engineer. Like they say that an engineer is basically a failed musician. So there's a saying which is kind of true in the sense that they found more business maybe because music business is too populated with people. There's a lot of competition. So it kind of mixes. The people like me who write in the center. So for certain things, I need tools which need to give me that detail. And For other processes, I just want it to be like a tape processor. Honestly, for me, I don't need to control the wow in Flutter. I want to slap it on so it absorbs the frequencies, what really the tape is doing, and get it out of the way. There are people who want to design their own tape machine. And for them, they need a product which controls all of this, right? What's the deviation like? What's it over time? Is it chewing the tape so much? And I want to control all those aspects and design my own tape machine. So then again, like it comes from that. It's not regional. It's more, who you are. Who are you?
Yeah. Tugirl asks a question. I'm not sure if you have an answer for this, but they ask, what is the fine line between donation and commercial products? Is there a way that we can commercialize donation products?
Actually, I do have an answer for this in a way. If you look at it like a subscription model versus a single paid product, I would say that, because that's what it kind of leans towards. We have not done a donation model, so the pure donation system I've not tested. I honestly, like you said, I can't answer on behalf of anyone who has. But we are like leaning towards building a parallel subscription, which is kind of like a donation, which is like, like a Patreon, in fact. So which is like, if you like the product, you can use it till the time, you kind of pay for it. When it comes to perception, you see, there is a perception also. So in my opinion, when you have a paid product and it has a certain price point and it looks a certain way and it has certain quality attached to it in its presentation, people tend to pay for it to also feel that they've purchased something of value. Immediately they start feeling kind of tangible, exchange of value, that I paid this and now I got this. And sometimes donation products can tend to be treated as, oh, that's just like a sketch product for me. It might really actually blow away some, like you've seen some free products blow away some of the paid products, but you'll still see people just buying the paid product maybe way over than even the free download sometimes. So why does that happen? That again is a perception of exchange of value. That's what I've seen, because they feel I've paid $49. Now I'm going to get support on this plugin. And if there are updates on this plugin, I'm going to go for it. Whereas when they look at a donation product, they're like, I don't know what investment went into manufacturing that product. Does it even work? Will it stop working? Will it mess up my project? So I'll keep it on that, that rough system of mine out there where I can experiment and see how this goes. So I don't know. I mean, that's what I've come to understand a little bit. Maybe I might be wrong, like totally, I don't know.
I think that you make a great point, which is that that you really just have to understand your customer. There are some people who have business models that are actually counterintuitive to what most people would think would work. One that comes to mind for me is Matt Titel's Vital synthesizer, which is a synthesizer that is fully fledged. It could very well be a commercial product, and it's open source, and
I think your mic went off.
Yeah, it went off and it turned back on. It's been doing this the whole thing. I'm not sure what's going on with it. Universal Audio, send me another sound card. That'd be awesome if they did. But anyways, so Matt Titel's Vital synthesizer is actually just donation. You pay whatever you want for it, and it's actually open source as well. And it's got amazing DSP. It's phenomenal. It's beautiful OpenGL graphics. Very well could have been its own commercial product. I don't know how much he's earning out of it, but he's been successful. He's been able to live off of that.
I'm sure.
But it's one of those where he's delivered above and beyond, the call. A lot of times donation products are just the bare minimum of what makes a product.
I'm sure, again, like you say, it's a perspective. We don't know for sure. We might be like super successful and, we just might be, putting on. But I guess I think probably a product like that will compel people to feel the value, I suppose, and pay. So it also depends on the product itself, where this experiment might be working phenomenally. We wouldn't be aware, but it just might be working phenomenally because it's just such great a product that people just can't ignore it. They have to get their hands on it.
Exactly. Great. Yeah, I think we've given a lot of great advice. Sorry, that's my dog, Toast, always making her contribution to the meetup. Is there anything else that we should add before we wrap up? Anything else you'd want to discuss?
Me, no, I think it was great insight from actually Stefano's, contribution to this thing. I mean, I'm like, mine must be very boring and the least of things people want to deal with. But the stuff he was explaining and all of that was, I mean, I've learned something. I'm going to take away something from this interaction. And yeah, just to add to that, like I said, one thing is developing a great system which works, and the other thing is marketing, and marketing becomes an entirely tedious, continuous stuff that developers don't want to deal with. But like I said, this is a great period for people to get into development because of tools like Juice, and because of access to third-party libraries like Stefano's libraries, and build what they want to build, and not even have to have a team of 20 people or 30 or whatever. Just start as a single person and probably make $1 million company in a year. You never know. It just depends on the product. So I would say it's the best time if you wanted to be a developer. This is the best time to probably do it.
Yeah, it's not a bad time at all. It's talks like yours and Stefano's that have really brought out an awareness that I don't think existed a few years ago. Just hearing people talk about these aspects of software development and plugin development.
And also the audio programmer, if I may add, I was saying this earlier, was that Josh and I have been friends, like he said, for a while. And it's, to be honest, when I was in the middle game of Beats, the third year out, and I was, going to get more serious into audio development. And his channel I found, and I'll be very honest to admit, there's so much I learned from that to get back onto, audio programming and Juice. And then he's personally gone out of his way to help me. So I cannot, not mention that. Plus his company of developers and all. Whenever I got stuck, I was always confident I could call Josh and he would like personally help me, or, get his team to, help us solve certain problems or develop, an entire system if we needed to. So I think the audio programmer channel itself is like, can you imagine we have something like this today, which is bringing on people to, showcase their brilliance and opening this landscape, which was a secret and so hidden and so private and so, under lock and key. It's finally exposed, giving, people with great ideas now an opportunity to quickly learn from the audio programmer channel, get started with your basic plugins, get started with, your foundation, and then go on to probably advanced tools like from Orastron and, get into something which is built out for them and put it together. So kudos to the channel, I would say, and to Josh.
Second to that.
Thank you very much. Thank you for the kind words. Yeah, and it wouldn't be anywhere without people like yourselves to spread that brilliance. And I really appreciate your ability to share and to just open your knowledge to other people. Like you said, there could be a tendency sometimes when you have the knowledge to sometimes people want to hoard the knowledge and feel that if I spread it, that other people will steal it or they'll take it or they'll copy it. And what we don't realize is that people are living their own lives, and a lot of people, they don't have the time to just divert from what they're doing to look at what you're doing and saying, oh, I'm going to do the same thing. This thing of open sourcing and spreading knowledge, I think really just puts a great karma into the world, and that it's there to help document these things for future generations of audio developers to come. So great. We're still getting questions in. Shall I go through for both Gaurav and Stefano? Shall I just fire these away before we sign off?
I'm good, yeah.
Okay. Very quickly, Gaurav, how important is it to have a segmented market, targeting just initial plugin users versus experienced engineers? This is a question from Joaquin.
Very interesting question. I didn't think of it like that, but I think automatically, I think I just went for the beginner market first. So that worked out well for me because I could ease into the business without, hurting myself too much. The stuff I didn't know about at that time. So yeah, probably the beginner market is maybe a good way to start.
Yeah. It's like sometimes I think one theme that I've taken away from this is that you've got to go with what you know, right? Like, 70s and 80s sounds, that style of music, what that market is like, what that audience is like. You've had the experience in there as a composer, and that's what you've used to fuel your product ideas. And that's what I always tell people is, if you're a guitar player, make a guitar product because you know about what people in that space want more about it than what the average person would know. If you're a DJ like myself, I'm very keen to know what sort of things I like in the DJing market and what things I don't like. So that would be the market that I would go towards. So you have to go. It's easy
to fall into that trap of, hey, this is popular, I think I can make a plugin which can be better. And you know nothing about it, but just going by what you think is the market demand. You can really fall into that and hurt yourself. So
yeah. That doesn't work. That doesn't, well, in my experience, when I've tried that doesn't work, because by the time you've caught up to the knowledge base of what it takes to make a product like that, the market has passed you by. And, whereas what you've done is you've started on a ground level with your products, and it's taken a little bit of time, but that the wave has come around and you've been right there. And then once again, people say, oh, Beat Skills is successful with the products that they're making, I'm just going to copy them. By the time they figure out how they, getting through the development cycle, getting their products out and everything, that's already passed by. So gotta go with what you know. Stefano, Wave Morpher has a question. Is there a benefit from using a filter rather than a linear interpolation for smoothing parameter values?
That's a good question. In certain cases, yes, but it depends on the kind of parameter you're controlling. Usually, I don't know, for example, certain filter in general, it works more smoothly with filters, especially for filter parameters. But there's no general rule that I know of. Use whatever works best for you.
Yeah. And there's another question from Wave Morpher. How is using a filter? Oh, this is actually the same question. He was actually just really curious. So we answered that. Okay, great. Yeah, I think that's it, and I think that's a good place for us to end the meetup, actually. So yeah. So thank you very much, Gaurav, for sharing your insights.
My pleasure.
And I think this is awesome. This wasn't intentional, but it felt like there were two different aspects here. There was one aspect that was like a DSP creation aspect, really homing in on the minutia of creating an awesome DSP algorithm, and then that being a critical part of making of making a product or of making a plugin. And then there's the 360 aspect, which is the marketing, the communication with people. How do you create a story and a product that's compelling? How do you actually communicate with and support your users? Which is another critical aspect. So, and it feels like there are some great sides, and you can gravitate towards one side or the other side, and it's still all successful. So there's no one road in this field to success. You can there are multiple roads to that pot of gold, so to speak.
Yeah, it felt like those two talks sat together really well tonight.
Yeah, absolutely. Thank you very much for your time, and I'd like to give a thanks to the sponsors again, Focusrite, Sonics, and Juice for sponsoring the Audio Programmer Meetup. And without them, we would not be here. I wanted to mention the next Audio Programmer Meetup. I always forget to do this.
Yeah. Timar told me to remind you.
Yes.
I was just about to jump in.
Were you? Do you have the date?
I think it's the exact same date as this month because of us not being in a leap year. So I think it is the 8th of March.
Yes. And while you did that, I pulled up my calendar quickly and I can confirm that it is indeed the 8th of March. So that's the next meetup. And as we mentioned before, we're always looking for talks, looking for people who are curious about sharing their ideas. You don't have to have 20 years experience in this field. Please share your ideas. We would love to hear from you. The link is in the description in the video. And with that, I'd like to thank Rachel as well for being an awesome host for us. And
thank you. I just want to say a quick thank you to everyone that's reached out to me from the community following last month's Audio Programmer Meetup. It's been great to get chatting to a bunch of you, and I'm just proud to be part of such a friendly community.
Yeah, super awesome. Yeah, I feel privileged all the time about how welcoming people have been just over the past 3 or 4 years that I've been in here. I think that sometimes when you're getting when people are new to the industry, they can feel a little bit maybe hesitant and feeling like that more experienced people will say, oh, that's not the way to do it, or, oh, you're wrong, or, oh, you should have known this. In my experience, I've always found this community to be very welcoming and very, very inclusive in terms of sharing knowledge and getting to know other people and hearing their other stories. So that's awesome to hear, Rachel. Yes. So yes, we will be back March 8th. And with that, we will sign off. From all of us to all of you. Thank you very much. And I will end the live stream now. So
good night.
Take care, everybody.
Bye.
Have a good evening. Okay, we are signed off.